Good morning and welcome to Algebra 1 with Miss Betsy. Today we're going to be talking about how we subtract rational expressions that have different denominators. The text that I'm using is pre-algebra. It's not pre-algebra, it's Algebra 1 for Christian schools. It's published by Bob Jones University Press, and I'm using the second edition. I'm in section 12.6 on page 500 if you're using the same text that I am. Now before we get started today, I wonder if you can tell me, what is it? What's the only thing that you can break simply by saying its name? Well, that would be silence. As soon as you say silence, you've broken it, haven't you? So let's go ahead and dive right into this lesson, and by now you are getting more comfortable working with rational expressions. At this point you should be excellent in dealing just simply with adding together fractions, but now we're going to see that when you have rational expressions, that they're very similar to fractions in that you have a numerator and a denominator, but when you end up having a rational expression which has maybe a polynomial in the numerator and some sort of an expression containing a variable in the denominator, that while we have similarities in how we deal with these fraction-looking objects here, it gets a little bit more, tad bit trickier when you're subtracting rational expressions, because you have more than one term in the numerator that you have to worry about. So let's just go ahead and let me illustrate to you what I'm talking about. And I'm going to go ahead and use example number 1 on our text on page 500. And we have x minus 3 divided by x plus 1 over x plus 1, and from that we are going to subtract the entire expression x minus 4 over x plus 2. And our instructions tell us to leave in factored form. So, when we're working with this problem, what's the first thing that we need to do? Well, first we have to determine what the least common multiple is. Well, we have two separate factors. There are no common factors, so our least common multiple is simply the product of those two factors, x plus 1 times quantity x plus 2. So this is what we're going to use for our common denominator. Now, just as you know, when you add or subtract fractions, if you have a different denominator, you have to rename those fractions so that you have a common denominator. Same thing here when we have rational expressions. If the denominators are different, you have to rename them so that you have the common denominator. And our least common multiple is our common denominator. So what we're going to do is look at this and say, okay, what factors are missing? Well, I have a factor of x plus 1 in that first term, but I'm missing that factor of x plus 2. So I'm going to multiply both the numerator and the denominator by that missing factor, which is x plus 2, because as long as you multiply an expression by a value that's equivalent to 1, you don't change that expression. It looks different, but it still has the same value. Next, we're going to look and see what factor we are missing in this second rational expression. And at this point, I'm going to go ahead and erase my notes here. Remember, we're going to leave our answer in factored form, and our least common multiple is the product of these two binomials, product of x plus 1 times x plus 2. What factor are we missing? We're missing the factor x plus 1, so we multiply the numerator and the denominator by the binomial x plus 1. I'm going back here now and I'm enclosing these in parentheses so that it just jumps out at us that we're going to FOIL in the numerator. I'm not going to worry about coming up with the product of x plus 1 times x plus 2 because our instructions tell us leave the expression in factored form. And also the purpose of one of the things that you need to do when you're dealing with rational expressions is you reduce it by canceling common factors. So it doesn't make any sense to multiply the denominator together because we're looking for common factors that we can cancel. So what do we have when we multiply the numerator together? We have x squared plus 2x minus 3x gives us minus x minus 6 over x plus 1, x plus 2. And now we're going to subtract the second product here of x minus 4 times quantity x plus 1, and that gives us x squared plus 1 minus 4 is minus 3x minus 4. All of that over our common denominator, which is the product of these two binomials. Now, this is where it gets just a tiny little bit tricky. You know that when you're working with fractions, when the denominator's the same, you subtract the numerators, or you add the numerators together to combine them. We're not simply subtracting one term though. Here we are subtracting this entire expression. So the first step that you want to show is where you've actually done your multiplication or whatever work you need to do in the numerators of those rational expressions that you're subtracting. Now we're going to rewrite this. We have x squared minus x minus 6 minus this entire quantity minus, whoops, and I need to put that parentheses in there, minus x squared minus 3x minus 4. All of that is over x plus 1, x plus 2. And you heard me say, whoops, what was the problem? If I had not put those parentheses around that trinomial expression there, the only term that I would have been subtracting it would have been a minus x. But when you distribute that negative sign, remember the sign of every term in here is going to reverse. So let me go ahead and carry this up to right over here. We have x squared minus x minus 6 minus x squared. You know, I have these limitations with this board. Let me go ahead and erase this. Going to erase our problem. We now have x squared minus x minus 6. Subtracting that entire trinomial, I'm going to carry this up to the top of the board as I do the step. And this is where you guys have an advantage over me, because you can just continue going on your piece of paper. So we end up with x squared minus x minus 6 minus x squared plus 3x plus 4. All of that over our common denominator in factored form, which is the product of these two binomials, x plus 1 times x plus 2. Now what happened when we subtracted this? The sign of every term changed, didn't it? What do we do now? We collect like terms. That's weird. Did I do something wrong? Okay. X squared minus x squared, those cancel out. We have a negative x plus 3x gives us 2x, negative 6 plus 4 minus 2, all of this over our common denominator in factored form. Now what are we going to do next? Are we finished? No, we want to leave, our instructions say leave this in factored form. So our answer is going to be 2 times the quantity x minus 1 divided by x plus 1 times the quantity x plus 2. This right here is our solution. In this particular problem, there are no common factors to cancel. Very frequently in Algebra 1, they will manipulate the problems for you. Here, they would have manipulated this into a 2x plus 2, so that when you factored out the 2, you would have an x plus 1. So that you would have a common factor of x plus 1. They chose not to do that in this problem, because what they are emphasizing to you is that when you subtract a trinomial, you have to remember to distribute that negative sign, which has the effect of changing the sign of every term that's enclosed in those signs, that's enclosed within those parentheses. So that's example 1. Let's go ahead and look at example 2. Excuse me. Allergy season here in Texas, and I have been outside lots and lots, and I think that's what I have going on. Okay, problem number 2, we have simplify y over x squared plus xy minus x over xy plus y squared. Can we see that? Y over x squared minus xy, x squared plus xy, minus y over xy plus y squared. We clearly don't have a common denominator here, so we have to arrive at our common denominator. And how are we going to do that? We're going to factor each denominator. So x squared plus xy is equal to x times x plus y. Everyone see that? Xy plus y squared plus y squared is equal to y times x plus y. Okay, so what do we have for our common denominator? Well, we have x plus y, x, and y. We have 3 separate factors. So our common denominator is going to be xy times the quantity x plus y. So let's go ahead and look at a problem and see what we are missing here. Can we do anything with this yet? Well, let's go ahead and put our denominator in factored form, because remember, our purpose here is to simplify these rational expressions as we're combining them by canceling common factors. So what are we going to have? I'm going to change my pen, go back to a little bit darker blue, and we have y over x times x plus y minus x over y times x plus y. Now we need to multiply each of these terms so that we end up with our common denominator, which is supposed to be x times y, xy times the quantity x plus y. We have an x, we have the x plus y, we're missing our factor of y, so we're going to multiply this first rational expression here by y over y. We're multiplying by a value that's equal to 1. Now in our denominator for this first rational expression we have x times y times the quantity x plus y, which is our common denominator. Next, we're going to look at this second rational expression and see what we are missing. So what are we going to have to multiply by? We have a factor of y, and we have the factor of x plus y. The one that we're missing is x. So we multiply both the numerator and denominator by x. Carry out this multiplication, and what do we end up with? We have y squared minus, I'm trying to skip a step. We have y squared over x times y times x plus y minus x squared over x, y times the quantity x plus y. Everybody see what we're doing here? Now, we have a subtraction problem. We have a common denominator. We end up with y squared minus x squared, all of this over x, y times the quantity x plus y. Now, do not fall into the trap. Several different traps here. You can't cancel a y and a y and an x and an x. Or actually, something that would be really wrong would be to say, okay, there's two y's in the numerator, there's two y's in the denominator. Two x's in the numerator, two x's in the denominator, so our answer is 1. Not true. What is it that you can cancel? You can only cancel common factors. We have a factor of x, we have a factor of y, and we have a factor of the binomial x plus y. We don't even have our numerator in factored form yet. And I'm hoping that as you look at this, you're seeing that y squared minus x squared, that is the difference of two squares. That's a special product. The only way that you can possibly factor that is by recognizing it as the difference of two squares. So again, I'm going to go back up to the top of my problem, top of my board here, and I'm going to factor the numerator. And that's going to factor into y plus x times y minus x, all of this over the product x times y times the quantity x plus y. Okay? Do we have common factors here? Yes, we did. Y plus x, x plus y. Those are identical because, remember, addition is commutative. Doesn't matter which order. So this is x plus y. So we have factors of x plus y in common, and our final answer is y minus x divided by the product x times y. Okay? So you see that we have a lot going on in these problems. You want to take your time to do these, allow yourself plenty of space on your paper, and just be pulling everything together that we've learned about factoring. Now, we're going to talk about opposites and the fact that subtraction is not commutative, but there is a relationship between something like x minus y and y minus x. They don't have the same value, but there's a relationship between them that we can use to help us when we are subtracting rational expressions. And I'm having a difficult time coming up with a really effective way to show this to you. So watch this, think about it, look at your book, those of you who are in my class on page 501, 502. Make sure that you're understanding at least, oh, I can substitute this for this. I'd like for you to understand a little bit of why, but you have to know that you can actually use this relationship that I'm going to show you. In our book, they're asking us, what happens to the binomial x minus 4 if we multiply it by -1? Well, let's see. Negative 1 times x is a negative x. That looks like a 4. Is a negative x. Negative 1 times a negative 4 is a positive 4. So we end up with the expression negative x plus 4. So they want to show us this, that negative 1 times quantity x minus 4 is equal to negative x plus 4, which can also be written as 4 minus x. And this is the relationship that we're working towards seeing here. Okay, we started off with this binomial here, x minus 4. When we multiply it by negative 1, we have the related expression 4 minus x. Now, what we just did in the previous problem, we had a factor of y plus x in the numerator, I think, and a factor of x plus y in the denominator. We were able to cancel those because x plus y and y plus x have the same value because addition is commutative. Okay? X minus 4 and 4 minus x are not the same. Subtraction is not commutative because what we've done here is we've multiplied by a negative 1. So x minus 4, 4 minus x, those aren't the same thing. But let's go ahead and see what happens if we substitute in a couple of numbers. We're going to have x minus 4, and we're going to have 4 minus x. X minus 4, 4 minus x. Let's say that x is 2. So we have 2 minus 4, negative 2. We have 4 minus 2, which is a positive 2. What about if we do a negative 7? We have negative 7 minus 4, which is not over anything, which is a negative 11. We have 4 minus a negative 7, which is a positive 11. And what about if we just substitute in 0? Whoops. X here, we have 0. Doing the 0 here, I just got distracted. 0 minus 4, which is a negative 4. In our second problem here, we have 4 minus 0, which is a positive 4. So do you see a relationship here? Negative 2, 2, negative 11, 11, negative 4, 4. Yeah, the relationship that you see is that these two expressions here are opposites. And this is the relationship that you need to understand, because you remember way back when you were learning how to subtract signed numbers, you learned that subtraction is the same as adding the opposite. So let's just put that little note over here. Subtraction is the same as adding the opposite. And when you do something with subtraction that vaguely resembles trying to use the commutative property with subtraction, you end up with opposites. And that's an important relationship. So let's move on now and see what we have. Okay, now sometimes you're going to have to change, the book says, change the form of a denominator so you can find a common denominator. You might have to factor it, might have to tweak it, move it around a little, but you can't create it, of course, you can't change it into a form that is different from what you started with. So you can't change the value of that rational expression, and they're pointing out that you can think of rational numbers as having 3 signs, and I've illustrated this in class, and we'll just do it this way, just simply using fractions. If we have -4/5, you can just say that that entire fraction is negative. You could say that that's the same as -4 divided by 5, which is also the same as 4 divided by -5, because these are all going to have the same value. Remember that as just accepting that as a true statement. So sometimes it's going to be easier if you have your rational expression in one of these very different forms. So let's say that you wanted to add together 3/5. Do I really want to add? Yeah, 3/5 plus 2 over a -5. Now we've got a 5 and a -5 in the denominator. Not a common denominator at all. 2 totally opposite values here. You'd much rather have $5 in your pocket than owe your mom $5. Okay? So if you change this form of your rational expression, 3/5 plus, let me see, -2 over 5. You've got a common denominator now, don't you? You have not changed the value of this expression. You've changed the form of it, but you haven't changed the value of the expression of it. And now it becomes an easy problem. 3 plus a -2 is 1/5. Okay, and we're going to move on from there to what you can do with rational expressions. So what they say at the bottom of your page is you should be able to change any rational number or rational expression to another form by changing the position of the negative sign. Makes sense. These all have the same value. You cannot combine these two fractions here because you don't have a common denominator. Change this second one to a different form and you do have your common denominator. Okay? So now let's think about positive forms. We have this negative fraction here. What are 3 different ways that you can write 3/7? Well, 3/7 could be -3 over -7, which is the same as the opposite of 3 over a -7, which is also the same as the opposite of -3 over 7. Okay? Negative divided by negative is positive. -1 times this negative here, that's going to be positive. Negative times negative, that's going to be positive. These are a little bit convoluted looking, maybe a little bit strange to look at, but this is what they're trying to say. And I'm going to read the book again. I'm sorry, I rarely read the book. It says, this idea may help you see why we're able to change the sign of the operation and the signs of one factor in the denominator without changing the answer. Now this is where we're trying to illustrate it. We're trying to figure out exactly how in the world we can do exactly what I'm going to show you next. Okay, using this principle that when you reverse the order of the terms in a binomial with subtraction, you're actually ending up with the opposite of the original expression. X minus 4 is the same as the opposite of 4 minus x. They're opposites together. So let's look at example number 3. on page 402. We have subtract 4x over x minus 7. We're going to subtract 3x over 7 minus x. Remember I told you, and you know this, that subtraction is the same as adding the opposite. So we're going to add the opposite of this. 4 over x divided by x minus 7. We're going to add the opposite. We said that when you change, okay, we haven't even changed the order yet, but we're just simply taking the opposite of 7 minus x. We're just adding an extra step here, saying we're going to actually physically take the opposite, which means that we're going to multiply this entire expression here by a negative 1. So we're taking the opposite of that binomial, 7 minus x, and we're going to add that. So what do we have here? Now we have 4x over x minus 7 plus 3x over x minus 7. Addition is the same as adding the opposites. Remember earlier I told you that 7 minus x, x minus 7, we went through that process showing that these two expressions here are actually opposites. So we have added the opposite. Now we have a common denominator, and our solution, 7x over x minus 7. But you see we've got some key difference here. Subtraction, right there, is the same as adding the opposite. This is the relationship that they're trying to show you when you have expressions that appear to be the same, except you've got a negative sign in the reverse. Subtraction is not commutative. They have different values, but the relationship that they have is that they are opposite of one another. You can use the truth of the statement that subtraction is the same as adding the opposite to come up with another form of this expression, another form of this rational expression here that allows us to manipulate the form so that we have a common denominator. See, we have this right here would be like saying the opposite of A over B. Right down here we have A over the opposite of B. That's the difference that we made. A over the opposite of B. But in order to subtract, you have to add the opposite. Okay, I'm sorry I said it's being a challenging concept to try and teach. Look at this, think about it, go ahead and try your problems, read your book, scratch your head, ask God to help you figure it out. Let me show you this last problem here. X squared plus x minus 9. All of that over the quantity x plus 2 times quantity x minus 5 minus 2x squared plus x plus 1 x plus 2, 5 minus x. Pretty close here, but I'm going to take a second and make sure I've copied everything correctly. X squared plus x minus 9. We're subtracting a trinomial sum, 2x squared plus x plus 1. Okay. If we change this term here, so we have a common factor, I didn't mean to say term, we change this factor. We have two common factors here. We have x plus 2. We have x minus 5 and 5 minus x. And that's the opposite. So we can change this bottom denominator here to its opposite. So we have x squared plus x minus 9 divided by the quantity x plus 2 times quantity x minus 5. I'm going to leave that sign there in the middle blank for a minute. We have 2x squared plus x plus 1, all of this, over x plus 2. Now we're going to change this term here, this factor here, to the opposite. And we're going to have x minus 5. We can't, these here don't have the same value, they're opposites. So what you do is you compensate by changing to the opposite operation. Subtraction is the same as adding the opposite. Okay, this is what you're doing. Subtraction, 5 minus x, we add the opposite. And now we are at the point where you can combine your numerators and you can simplify because you have a common denominator. So we have all of this now simply an addition problem. So we're going to add together over our common denominator. X plus 2x minus 5. We have x squared plus 2x squared, 3x squared, x plus x, plus 2x minus 8. All of this over x plus 2, x minus 5. Now you need to factor our numerator here and see if we have any common factors that we can cancel. This video has gone on forever. You guys know how to factor trinomials. 3x minus 4x plus 2. So I'm not going to do it. 3x minus 4, x plus 2. You know that there is frequently a little bit of trial and error that's involved in factoring this, but you can verify that this is true. 3x times x, 3x squared, plus 6x minus 4x gives us our plus 2. Negative 4 times the positive 2 gives us our negative 8. And of course we do now have common factors here that cancel. We have common binomial factor of x plus 2 to give us a solution 3x minus 4 over x minus 5 to having the sum of these two rational expressions. What I want you to see is that subtracting something can be the same as adding the opposite. Okay, play around with those, text me if you get stuck, and I'll see you soon.